Let's see how to do this question from JEST 2024. Let small q and small p be the canonical phase space coordinates of a system where q is the generalized coordinate and p is the generalized momentum. Let us make a transformation of generalized coordinate as capital Q is equal to small q square. Which of the following functions is canonically conjugate to capital Q? So this is a question from canonical transformation. The condition for canonical transformation is the Poisson bracket of new variables with respect to old variables. This should be equal to 1, or you can say Poisson bracket of old variables with respect to new variables should be equal to 1. This is the condition of canonical transformation. Now, how is Poisson bracket defined? Poisson bracket of a comma b with respect to small q small p, this is equal to, you will write del a del b as it is 2 times, and in between you will put a minus sign. In the denominator you will write del q del p, then you will change the order, you will write first del p and then del q. This is how we define the Poisson bracket. Now if there are multiple qi's and pi's, then this will be a summation over I, qi, pi. Here also there will be pi, qi. But in this case we only have one small q and one small p, so there is no need of summation. Let us find Poisson bracket of capital Q capital P with respect to small q small p. This is equal to del q del p minus del q del p del p del q. This is equal to, now we are given q is equal to q square, it is given in the question, and we have to find the canonically conjugate quantity to capital Q. Now what is canonically conjugate quantity to capital Q? It is P. Canonically conjugate quantity to capital P is capital Q. Canonically conjugate quantity to small q is small p. Canonically conjugate quantity to small p is small q. So you know this, right? Canonically conjugate quantities are the coordinate and momentum, corresponding coordinate and momentum. Therefore we have to find this thing, we have to find capital P. Which of the following function is canonically conjugate to capital Q? So according to option A, we have capital P is equal to small p divided by 2q. So option A is saying that capital P is small p divided by 2q. Let us check by putting in the Poisson bracket del by del q. Capital Q is q square, del by del p. Capital P is p by 2q minus del by del p. Capital Q is q square, del by del q, p by 2q. This is coming out to be equal to, when you do this differentiation you will get 2q times, when you do this differentiation you will get 1 by 2q minus, this is nothing but 0. Therefore we have 2q times 1 by 2q is equal to 1. Therefore the condition of canonical transformation is satisfied and option A is the correct answer. Now you can check option B, option C and option D in the Poisson bracket, and you will see that the Poisson bracket will not come out to be equal to 1.